Assalamualaikum. My name is Muhammad Maliki, and today I'm going to share with you guys about our project, which is PALF ceiling. Okay, so first thing is I wanna introduce to you guys about our project. Pineapple leaf fiber, or we call it PALF, is one of natural fiber that can be found naturally in pineapple fruit. Natural fiber can be used as an alternative to synthetic fibers for reinforcement in polymeric composites that are predominantly used as structural components in lightweight applications. Transitioning from synthetic to natural fibers can be beneficial from an economic, environmental, and societal standpoint in the current state of the sector. Engineers and experts are still interested in this topic of research. Natural fiber composite offer solutions to the non-renewable resources now in use, rather than using asbestos in our project. Natural fiber composite have been shown to have superior mechanical qualities, improved electrical resistance, great thermal characteristics, superior tribological attributes, acceptable acoustic insulating feature, and better fracture strength. Recent research on natural fiber composite in particular has revealed that the mechanical properties of natural fiber reinforced composite are comparable to those of glass fiber composites. Natural fiber reinforced composites in the form of panel, tubes, and structural sandwich have previously been used to replace wooden furniture fixtures and fittings, as well as noise-absorbing panels. Okay, in the usual fiber composite that we use, there are a lot of problems. Okay, the most common fiber on the market is asbestos ceiling. Asbestos has various advantages, such as its natural fiber resistance, which makes it suitable for roofing, flooring, and thermal installations. Because the material does not burn easily, it is not recommended to use it near electrical components. However, there are certain drawbacks to using asbestos as a ceiling, such as health risks. There is a need to find an alternative in the form of natural fiber to find this solution. Pineapple, palm oil, and sugarcane bagasse are examples of natural fiber. This research will look into the possibility of using sugarcane as the primary material for ceiling board production.
Assalamualaikum and hi. My name is Muhammad Zaki bin Zainal and my metric number is AA200554. And now I will be continue to objective of this study. They have three objectives. First is to analyze the physical properties of PALF-based ceiling. Second is to analyze the thermal properties of PALF-based ceiling. And third is to produce PALF-based ceiling with aesthetic value. Next is the scope of study. They have a scope of study. First, this study will be conducted based on the industrial visit on the production of pineapple fiber around Pontian district. And it is also important to get the information on conventional ceiling size, properties, and procedure. Next, they have some laboratory tests, which is strength test and bending test, moisture content test, thermal conductivity test, and water absorption test as the experimental in this project. And finally, the sample of ceiling will be compared to know the difference of the conventional ceiling board and the pineapple leaf fiber board.
Okay, for the expected outcome, the expected result for this study is to be able to produce PALF ceiling both with standard size for use in industry. The PALF ceiling produced should be environmentally friendly and height resistant to heat. In addition, the durability of ceiling sample made of pineapple fiber against water absorption and competent against bending.
Okay, now we move on to the chapter 2, which is literature review. In literature review, pineapple leaf fibers are a form of plant fiber derived from the leaves of the pineapple plant, which is a vegetable fiber or natural fiber. The pineapple plant, also known as Ananas cosmosus, and belonging to the Bromeliaceae family, produce a variety of seasonal harvest plants originally arrived from the Brazil and were transported to Indonesia by Spanish sailors and Portuguese in the year of 1599. The plant is already commonly found in Indonesia, particularly on the islands of Java and Sumatra, where it may be found in Subang district, Majalengka, Purwakarta, Purbalingga, Bengkulu, Lampung and Palembang, among other places. The pineapple leaf has a sword-like shape, is tapering at the end and has a blackish printing with a sharp thorn on the edges. Pineapple leaf vary in length from 55 to 75 cm, breadth from 3.1 to 5.6 cm, and thickness from 0.18 to 0.27 cm. It depends on the species or plant kinds. The outer layer of pineapple leaves made up of top and bottom layers. Many bonds or bundles of fiber exist within the layer, which are held together by a type of adhesive found in the leaves. Okay, now let's talk about the pineapple industries in Malaysia. In Malaysia, the pineapple industry has been contributed to the global pineapple production in 2013 was estimated about 315.977 metric tons. Within the late 1960s and early 1970s, Malaysia grew to become one of the top 3 pineapple producers in the world, thanks to the pineapple being the first crop farmed as a commonly crop with great export potential in the country. However, the country's ability to remain competitive has suffered a major setback. This loss has been linked to a number of factors, including pineapple farmers' decision to convert to other crops, such as palm oil, which they believe would be more profitable and easy to produce. The pineapple industry in Malaysia has been suffering from a lack of land for cultivation. The loss in pineapple plantation area was primarily recorded among the smallholder sector until 2007, when the industry saw an increase in plantation area. Despite this, the annual drop in pineapple plantation area continued until 2011, with the plantation area was 1,310 hectares.
Next is the manufacturing of PALF. Natural pineapple fiber have excellent mechanical strength, but they are still underused nowadays. It can be used in a variety of ways, include artificial fiber as a sound absorber and as a thermal insulator. And the puff can be extracted in a variety of ways, which is the scraping method and the writing method. Next, let's go to the scraping method. Scraping machine is a machine that scrapes the pineapple leaf fiber, and the machine is made up of 3 different rollers, which is first one is the feed roller, second one is the leaf scratching roller, and the last one is a serrated roller. The feed roller is used to feed leaf into the machine. After that, the leaf pass through to the scratching roller. It removes the waxy layer from the upper layer of the leaf by scratching it. And finally, the leaf reaches the densely attached blade serrated roller, which crush the leaf and create several breaks for the writing microbes to enter. Next is the writing method. Small bundles of scratched pineapple leaf are immersed in a water tank containing sustained liquor in a 1:20 ratio, urea 0.5% for quick writing reaction process. Many chemical constituents such as potassium, lignin, fat and wax, ash content, introgenous matter and pectin can be extracted from the material in water tank. After that, the fiber are mechanically sprayed by washing in upon water. Extract fiber are air dry in a hanging position, and puff can be extracted from chopped fresh pineapple leaf using both a ball mill and disc mill. And the method also produces more fiber and smaller fiber than traditional methods. But ball milling is the slower of the two mechanical breeding methods investigated, but it provides puff with a greater number of elementary fiber. Next is the analysis of puff. The increased use of biocomposite in industry has increased the possibilities for reducing the waste of renewable materials. Puff has a white color, is silky smooth, and has a medium length fiber with a high tensile strength. And it has a softer surface than other natural fiber and absorb and also hold color well. Puff, on the other hand, has a high specific strength and stiffness, as well as high cellulose content. And to remove fiber from pineapple leaf, a mechanical and retting method is performed. And the fiber content of fresh leaf range from 2% to 3%. After that, the vascular bundle system in the form of bunch and puff fibrous cell was obtained. Pineapple leaf fiber is the most compatible natural fiber resource and has a good chemical composition. Puff can be used as an excellent alternative raw material in the prospect of reinforcing composite matrix because of its unique properties. Next is the physical properties of puff. Natural fiber-based composites are environmentally friendly nature and unique properties. The advantages of it is being readily available, easy to handle, and biodegradable. Natural fiber have excellent physical and mechanical properties, but they are very depending on the plant source, species, geography, and other factors. Pineapple leaf fiber, or we call it puff, is one of Malaysia's abundant waste material that has yet to be studied despite the fact that it's needed. A thorough examination of puff physical properties will reveal logical and reasonable application for the material. Investigate a wide range of properties and behavior, including surface structure, morphology, tensile behavior, and the electric property. Puff has a good elasticity, and puff also has a high strength compared to other natural fiber.
Laboratory tests. There are several laboratory tests conducted based on product extract from pineapple fiber. These tests include strength and bending tests, moisture content tests, thermal and water conductivity tests, absorption tests. The result of the manufacture of sealing based on its main material, namely pineapple fiber, plaster, lime, and gypsum. The sealing with the upper surface is highly reflective, has good thermal dissolution, and low heat capacity are recommended in hot climates. It is the shell that hide the roof structure above it. Roof the structure can be ordinary pipe lead or acoustic lead and heat insulated. In modern building, the ceiling lead electric light, security camera, smoke detector and more. The ceiling need to be tested to assess the durability as follows. Okay, first test is strength test and bending test. Strength and bending tests are carried out to find out the ability of the sample to withstand the maximum load. Asbestos ceiling and pineapple ceiling will be compared based on their strength and flexibility. Textile preform are subjected to axial tensile deformation, in-plane shear deformation, transverse compaction and out of plane, bending deformation during composite reinforcement shaping. Okay, equipment needed for this test is hydraulic testing machine, ruler and knife. Okay, for the moisture content test, moisture content tests are conducted to find out the percentage of water on each type of the ceiling. The purpose is to compare the water content of asbestos ceiling and pineapple ceiling. Many moisture analysis methods are already available for commercial use. Spectroscopic, chemical conductivity, and thermogravimetric analysis are the most common method for determining water content. Okay, equipment needed for this test is digital weight measurement machine, microwave oven. Okay, for the thermal conductivity test is the property of base material that is associated with the easy with which thermal energy is carried through a particular material. Materials that are easy to conduct heat with a small applied temperature gradient have higher thermal conductivity than materials that are more resistant, more insulating to heat flow. If the thermal conductivity value is high, it is an excellent heat conductor, but if the value is low, it not. It is not. Equipment needed for this test is microwave oven and digital weight measuring machine. Okay, for the water absorption test, this test is carried out to measure the rate of water absorption in the mixture of PALF ceiling and asbestos ceiling. The purpose of this test is to compare the absorption rates between the two ceilings. Also, the problem of moldy ceiling is caused by moisture on the ceiling. Equipment needed for this test is digital weight measuring machine.
Okay, now we move on to chapter 3. In this chapter, we studied on how we observe and test the capability of the pineapple leaf PALF at Furniture Lab, EduHub, Paguh Muar, Johor. For this study, two types of pineapple were used, the Josopine and Morris pineapple. The moisture content of the fiber was determined using the moisture content test, as seen in figure 2.1. This study requires some planning, which is define objectives, the problem statement, and the literature review. And from the literature review, we got it from the previous research, and from library, which is book, journal, magazine, and the last is we got it from the internet.
Next is the field observation. The location of our project is to visit the Alu Bukit Nanas Station Plant, Jalan Kampung Melayu Raya, Pekan Nanas, Johor. Next is the PALF sampling. There have two types of pineapple leaf fiber, which is the spine and Morris. The fiber yield percentage of the spine type is higher than the Morris type. because of the larger leaf size and the easier extraction. As a result, your spine produces the higher percentage of yield when compared to Morris type. And the most suitable age for choosing pineapple leaf to get the highest maximum percentage is 12 months.
Okay, now I will share about how to process or extracting the pineapple leaf fiber. There are 4 methods to use to extract the pulp. The first one is chemical treatments, where the pineapple leaf were gathered from local resource, washed and dried in the sun before being powdered in a mixer grinder. The powdered sample were initially treated with a 2% sodium hydroxide solution before being magnetically agitated for 4 hours at 100 degrees Celsius. Several times wash it with distilled water and dry in an air oven. Okay, the second method is lime juice hydrolysis. Strong acids have been avoided for hydrolysis in the interest of environmental friendliness and green produce for hydrolysis. Lime juice has been implemented. Lime juice is mixed with 2 grams of bleached pineapple leaf fiber and diluted with distilled water in the 1/7 ratio. A diluted lime juice has a pH of 2.5. This is assured for 2 hours and mechanically stirred at 400 rpm. The excess acid was then removed by washing the solution several times with distilled water, and then we got the pulp. And the third method is ball milling. Ball milling is the colloidal suspension was ball milled in a planetary ball mill, which consisted of a 500 milliliter plastic container containing ceramic balls of various sizes. The bulk to support weight ratio is 18/1 ratio. The ball milling was done for 1.5 hours and 3 hours respectively. And the method number 4, which is we're going to use in our experiment, which is manual method. Manual method have already been used to harvest pineapple leaf fibers from prior studies and to some extent from the result of internet readings. The manual method of obtaining pineapple leaf fiber from the pineapple leaf section is one of the easiest and fastest way available. The following are the methods of extracting pineapple leaf fiber. First, choose, separate and clean the pineapple leaves that have been collected. The leaves are further divided into small pieces, and then the leaf bar is peeled open, allowing the leaf fibers to emerge. The leaf bar is also removed. The ribbed fibers are combined with a small amount of water and ground till they are finer. First, fiber is weighed and placed into a tin. Place the fiber in the oven for a few minutes at a low temperature, and the residue is reweighed when it has been complete.
Next is the sealing sample preparation. There have some procedure for making pineapple fiber sealings. First step is spray the mold box with oil. Second step is water is combined with lime in a 1:112 ratio until the lime is completely dissolved. And number 3 is apply oil to the mold box surface. And number 4, the mixture is poured on the top layer by layer, and the initial layer serves solely to cover the mold surface. Next, place the pineapple fiber lengthwise on the top of the first. And number 6, at the top of layer, put the pineapple fiber lengthwise. Ensure that all of the pineapple fiber has been used to fill the available area. And number 7, pour the second layer of the mixture over the pineapple fiber until it's completely covered. And number 8, flatten the layer top surface using a scraper. And number 9, dry for 30 to 40 minutes to complete the drying procedure. And lastly, after it's finished, the sealing is taken out of the mold and that's to cure for a few days. Next is the construction of mold. A good mold should have a good quality, such as they are need to have high quality tidy safety, construction cost, stiffness, strength, position, and also size. And there I have some procedure to making a mold for this project. First step is cut wood for the mold, both sides and base. And number 2, use nails to secure the wooden box sides. Number 3, attach the wood to mold box base. And number 4, the size of base is 15 cm multiplied 15 cm. And number 5, to avoid concrete defects, the installation should be done carefully with no small holes.
Testing on ceiling sample. There are several laboratory tests conducted based on product extract from pineapple fiber. These tests include strength and bending test, moisture content test, thermal conductivity test, and water absorption test. The result of the manufacture of ceiling is based on its main material, namely pineapple fiber, plaster, lamp, and gypsum. The purpose of this test is to find out the capacity of the ceiling produced from product from pineapple fiber and compare it with conventional ceiling in the markets. For the strength and bending test, are performed to determine the sample ability to withstand the maximum load. The strength and flexibility of asbestos and pineapple ceiling will be compared. Reinforcement of is a structural part. The autoplane properties cannot be inferred directly from the in-plane properties as the case with continuous material. A deflection frame apparatus, a 300 mm, 70 mm pineapple fiber ceiling, a 300 mm and 70 mm asbestos ceiling, a knife and a ruler are recommended for this test. For the procedure, the strength and bending test produced is to avoid drying of the surface. They should be performed on specimen after they have been removed from curing condition. Insert the specimen into the loading point. The specimen surface should not come into contact with the loading point. With the applied force center, the loading system bring the force resisting block into contact with the specimen surface at the loading point. Finally, calculate the average depth and height by measuring the cross section of the test specimen at each end in the middle. Okay, for the moisture content test, are performed to determine the percentage of water content on various types of the ceiling. The goal was to compare the moisture content of asbestos and pineapple ceiling. Pineapple size fiber ceiling 150 mm multiply 150 mm. Asbestos ceiling 150 mm multiply 150 mm. Scale, knife, ruler, microwave oven, and ceiling laying container are required. Okay, for the procedure, for testing moisture content test is clean and dry the weighing instrument container and then close the weight container after placing the same in each containers and sample should be weighed. Place the sample and container in the oven to dry at 105 and 110 degrees Celsius. Remove the sample and container from the oven and set the aside to cool in desiccator. Weigh the sample and the container. Okay, for the thermal conductivity test, is a property of a base material related to the ease with which thermal energy is carried through a specific material. Thermal conductivity is higher in materials that are easy to conduct heat with a small applied temperature gradient than in the materials that are more resistant and insulating to heat flow. material thermal conductivity change with the temperature, and the higher the temperature value, the lower the thermal conductivity value of the material. A micro oven, a digital weight measuring machine, 3 pieces of asbestos sealing sample, 3 pieces of different pineapple fiber sealing thickness, and 3 pieces of different pineapple fiber sealing thickness are required. The procedure for this test is thermal conductivity test. Process with a heat diffusion test is performed to determine the effectiveness of the sealing with a measure of pineapple fiber. As a good thermal insulator, this heat test is performed in an oven. Prior to testing, the weight is recorded. There are 3 pieces of sealing to be tested at each temperature. In the end sample setting, a test for each predetermined temperature are averaged. The heat diffusion rate is calculated as a percentage. Okay, for the water absorption test, the purpose of this test was to determine the rate of water absorption in a mixture of PALF and asbestos sealing. The goal of this test is to compare the absorption rate of 2 different sealing. During this test, weight instrument as well as 3 samples of each type of sealing produced were required. 3 pineapple fiber sealing sample and 3 asbestos sealing sample. For example, measured 150 mm multiply 150 mm. For the procedure of water absorption test is the test is carried out by taking the initial absorption sample test with water at laboratory temperature. In this way, the measurement, the actual absorption of the sealing sample under normal condition can be known. After soaking, the sample is removed, dry and weighed using an electronic weighing machine. Water absorption test is conducted at 3 time stage, namely 24 hours, 48 hours, and 72 hours. 3 main samples were divided into 3 sub-samples to undergo this test. The sample is weighed before the test is carried out and reweighed at the time set, namely 24 hours, 48 hours, and 72 hours. Okay, for the conclusion to the chapter 3, conclusion should be drawn with the goal of understanding the study in relation to the revenue generated, strength and bending test, thermal conductivity test, moisture content test, and water absorption test are all used to evaluate the physical and chemical properties of category sealing type. Such tests revealed that pineapple fiber type sealing still have some shortcomings when compared to asbestos sealing, proving that it is state that recommendations are required to improve the quality of the sealing produced with different to the result and comparison of each test produced against the pineapple fiber and asbestos sealing.